So this session is to help you with practicing your stoichiometry. When you're doing the stoichiometry problems, there are a few things that you have to do. Number one, you've got to balance your equation. When you're given the equation, do not assume that it's balanced. Always double check. Sometimes it will be, sometimes it won't, but always double check. In your first conversion, you're going to run mass to mole. In the second conversion, that's where you're going to go mole to mole, and then your substances change. So you start with your substance A, and that's where you switch change O to substance B. And then last but not least, in the third conversion, you're going to go from mole to mass. So in this example, you've got the decomposition of hydrogen peroxide or dihydrogen dioxide into diatomic oxygen and to the dreaded dihydrogen monoxide. And this is the reason why they put hydrogen peroxide in darkly colored bottles, because when it hits light, it causes the decomposition of the hydrogen peroxide into oxygen gas and into water. So if you leave it uncovered or not closed tightly, and you leave it for a while, what ends up happening is it actually turns into oxygen gas and water, which is definitely not hydrogen peroxide. But in this case, I'm asking you how much diatomic oxygen is produced when 200 grams of H2O2 decomposes. So you go back to your first example, or your first step, which is you've got to balance your equation. And in balancing your equation, you have to identify the number of atoms you have on each side. And in each of the cases, you've got to figure out, you've got hydrogen and oxygen. And on the left-hand side, you have 2 hydrogen and you have 2 oxygen. Then on the right-hand side, or your product side, you have 2 hydrogen. And then for oxygen, you have 2 plus 1. Now, some of you will go ahead and put 3 there, but I put 2 plus 1 to remind me that my coefficients can change the overall number. So my hydrogens are balanced, and I don't really have to fool with those, but my oxygens go from 2 to 3, and that really can't happen. I know from experience that if I change this oxygen from an odd number to an even number, life gets easier for me. So I'm going to put a 2 there. And when I do that, it's going to change my hydrogen to 4, and it's going to change my second oxygen to 2 to instead give me an overall oxygen number for 4 rather than 3. So then I look and say, well, okay, I need 4, basically, hydrogen and oxygen, and so I can put a 2 out there. So that's going to give me 4 hydrogen, 4 oxygen. It's balanced with my hydrogen and my oxygen. So my overall equation is balanced with a 2 and 2. Now, with the stoichiometry, it's asking you how much O2 is produced when 200 grams of H2O decompose. So I'm going essentially from 200 grams of H2O2 to some number of grams of diatomic oxygen. So I'm going to write down what I was given, and then I'm going to set up my equation. So 200 grams of H2O2. My first step, I said I needed to go to mass to mole. So I'm going from mass to 1 mole of H2O2. Well, in that step, I need to be able to cross-cancel my grams of H2O2. I need to be able to cancel those out. So that dictates that my grams of H2O2 goes in the denominator. Then my next step is mole to mole. Well, I need to get rid of my mole H2O2, and I want to change it into moles of diatomic oxygen. So that's why the moles of O2 goes up top. Then in my last step, I'm going from moles to mass. So I'm going to put 1 mole of O2, and I'm going to put it underneath my grams of O2. Now, what have I done here? There are a couple of things. I want to point out that in the first and the third step there, you have 1 mole of a substance is equal to some number of grams of a substance. Well, where do you get those? Where do you get the grams? Well, in this case, I'm going to take H2O2 and I'm going to break it down. And I'm going to find the molar mass. I have 2 atoms of hydrogen, I have 2 atoms of oxygen. I look on my handy dandy periodic table, and I'm going to find that I have each hydrogen is at 1.01. I'm going to multiply it by 2 to get my total mass for hydrogen at 2.02. Then I look and I find the mass of oxygen, which is 16. I multiply it by 2, and I'm going to get 32. Then I'm going to take both of those, I'm going to add them together. So my molar mass of H2O2, 1 mole of it, is 34.02 grams. Okay. And then I'm going to go and I'm going to still deal with my molar mass for grams of O2. So I have oxygen, I have 2 atoms of it. Each of them are worth 16. The total is going to be 32 grams. So 32 grams of oxygen makes 1 mole of diatomic oxygen. Then you wonder what about the numbers in the middle? Where do those come from? The numbers in the middle come from the balanced equation. So I have to look back at my balanced equation, and we're going to find that it was balanced with a 2, 1, 2. So my moles of diatomic oxygen were 1, so I'm going to put a 1 right there. And then my moles of H2O2 were that. You had 2 of them, so I'm going to put a 2 right there. So next, I'm going to create a little bit of space here. The first thing I've got to do, and yes, I go ahead and do this every time, I'm going to make sure that I've got everything set up correctly. And I have to do that by seeing what cross cancels. Grams of H2O2 cancel with grams of H2O2. Moles of H2O2 cancel with moles of H2O2. Moles of O2 cancel with moles of O2. I'm left with grams of O2. That's what I wanted in my answer. So it looks like I'm okay. So now I'm going to take all the numbers in the numerator and I'm going to multiply them together. And I'm going to take all my numbers in my denominator and I'm going to multiply them together as well. And I'm going to get my 2 numbers. So when I multiply all my numerators together, I'm going to get 6,400. Then I multiply my denominators and I get 68.04. Then I have to go ahead and do my division. And some of you like to do this in a long, big stream. I can't make the calculator work that way. I end up getting it confused, and so I do this the old-fashioned way. So my answer would be 94.06 grams of oxygen, or diatomic oxygen. And that is my answer. That's what I'm looking for. So I hope this was helpful, but remember that you have to balance your equation. Then you're going to go from mass to mole. The middle section is mole to mole, and then the last one is mole to mass. And in deciding what comes next when you're filling in your steps, you have to be able to cross-cancel. You have to be able to work backwards and cross-cancel. Always keep that in mind. Good luck, and thanks.